Yeah, good morning, students. It's my pleasure to introduce this today's topic for discussion is on stacks. So today we would like to discuss about what is a stack and what are the different operations we can perform on stack. Fine. So now I would like to share my screen. Hope my screen is visible to you. Yeah. So this is CDT 11 week 4 lecture 2 stacks topic. So in the previous classroom, we had a discussion on these two-dimensional arrays, how dynamic memory allocation functions, MLOC or CLOC, can be used in allocating the memory for 2D arrays. And we discussed about the different types of two-dimensional array operations like matrix addition, matrix multiplication. Fine. So now today we would like to discuss about the topic on stacks. So the lecture objectives is that how we can use arrays for representation of the stack data structure, and then what are the different operations on a stack we can define, just like insert and delete operations, which we can call it as push. This is called it as insert operation, and then this is call it as a pop is called it as a delete operation. Fine. So the outcomes of this today's session is that upon completion of this session, students will able to implement all the stack operations by making use of arrays. Implementation of stack operations by making use of arrays. Fine. So how do we define a stack? A stack can be defined as follows. It is an ordered collection of homogeneous data elements where the deletion operation and insertion operation takes place at one end only. Got the point? So it is an ordered collection of homogeneous data elements where insertions and deletions can be done at only one end. So in stack, that means here, for example, if you take this is an array. Okay, so for example, this is an array if you take it as. So array of size, suppose if you take it as 4 elements. So you can insert an element from this end only, and you can delete the element from this end only. So that is one, from one end you can do the insertion, and other end you can do cannot. This is a closed end and this is the open end. You can see that insertion and deletions can be done from the same end. That is a push operation, and the pop operation can be done at the same single end only. Fine. So that is what we are calling it as a top. We are taking it as a index variable. Top we are taking as the index variable as a top, and from this top end only we can do this insertion. So in stack, insertion and deletion takes place only at one end. These operations are called it as a push and pop respectively, and the position of the stack where these operations are performed is known as the top of the stack, we can call it as. Got the point? So this is what we are calling it as here. This is a push operation we are performing, and this is a pop operation we are performing, and from this end only, from the top end only, we are pushing an element or we are inserting an element, or from the top end only we are deleting an element. So how do we represent the stack? So stack can be represented either by making use of a one-dimensional array we can use. This is called it as array representation. And another one is we can use a single linked list we can use. And this is called it as a linked list representation of this stack. So stack can be implemented either by making use of arrays or by making use of linked list. So we will see these two types of implementations in the coming sessions. We will see that. So now we are going to discuss about array representation of the stack. So how we are representing that array and how we are representing this operation. So suppose this, if you take this is a stack, you can take it as yes. So we are inserting 1 on top of that, 2 on top of that, 3 on top of that, 4 we are inserting that. Now the top is pointing at this index location. Got the point? This is the array 0th index, this is array's first index, this is second index, and this is the third index. Now when you want to insert a new element, Now you can insert a new element on top of this 4 only, you can insert that. For example, I want to insert 8. Now this top is moved from position index position 4 to index position 5 after inserting this element. Fine. So this is what the push operation we can call it as. So like this, for example, 2 we are pushing, then after that we are pushing 8, after that we are pushing 9. So now the top is at second index location. These are the indexes of the array. So this is the top always pointing to an index location in the array where the topmost element is present. Fine. So this is what we are calling it as a stack. Fine. So if I want to remove an element, that is a pop an element. So where the currently top is there, so you can pop this element. So that is, you can remove this element from this array. Then the top is decremented so that it is pointing to this top minus minus, so it is pointing to this first location. This becomes it as a topmost element in the array. So like this, here we are going to implement the basic operations of the stack. So that is a push operation which inserts an element into the stack, pop operation which removes an element from the stack, and another operation is that to know the present state of this stack, the status is another operation. That is nothing but what are the elements which are currently available in the stack, we can see that. So stack operations with an example here. Initially, we are assuming that a stack of size, an array of size 5 we are taking here. So maximum size of the stack is 5. Now initially top is pointing to -1 location. Fine. So if we want to insert, if we want to push an element 3, push of 3. So now I want to push an element 3. So if you want to push an element 3, so you have to increment the top, and then in this new top location you have to insert that element. So now top is pointing to 0th index. So next operation is push 6. If you are calling that, now top is incremented to 1, index location 1, and in that you have to insert this new element. So if you want to push 9, then you have to increment the top, and in this new top location, that is the second index location, you have to insert 9. So like this, a sequence of push operations, if you perform that, so we are pushing these elements here 3, 6, 9, then push 10. So now top is at third index location. So again, if you want to push 11, top is at fourth index location. So if you want to push 15, now because there are maximum 5 elements in the stack, the size of the stack is 5. So we can say that stack is full as top is equal to size -1. So this is the condition we have to write if you want to check whether the stack is full or not. When the top is equal to size -1, because the index is always starting from 0. So the size of the stack we have taken it as a 5. So 0 to 4 is the index locations. Fine, got the point. So if top is equal to size -1, so size we have taken it as a 5. Maximum size of the stack we have taken it as a 5. Once top becomes it as a 5 minus 1, 4, then we will say the stack is full. We cannot insert a new element 15 into the stack. So now if you want to pop that, so you can pop this topmost element in the stack. So what is the topmost element? 11. So 11 can be popped, then top is decremented. So it is pointing to the third index location. So like that, a sequence of pop operations if you do that. So pop again, third time if you call the pop operation, so third element is removed here, 9 is removed from that. So top becomes 1. So top is pointing to this index location 1. Fine, top is pointing to this index location 1. So like this, if you are pushing, if you are popping this element again, 6 will be popped up, 6 will be removed. Now top is becoming 0, top is pointing to 0 index. Then again if you call pop again, so it 3 will be popped here. Then after popping this 3, now top is equal to top -1. Again if you call pop again, so it is now it is going to display stack is empty. There are no elements to pop. So when the stack is empty, once the top is equal to -1, you will say that stack is empty. So these are the push and pop operations, how we have performed with an example. So same thing we will implement by making use of these operations. Fine. So these are the operations which we can define on a stack data structure. Push, pop, is empty, is full, and then peek. Peek is an operation that returns the value of the topmost element of the stack without deleting it from the stack. So the difference here between the pop and peek is that, so pop will always delete an element from the stack. The that is nothing but the topmost element is removed. Here peek is it will not remove that element, but it will tell to you that this is the topmost element. That is the difference you have to identify, differentiate between pop and peek operation. Otherwise, both are same here. Display, it will print all the elements currently available in the stack. So these are the different operations which we can define on the stack, and we can implement those operations now. So if you take a push operation, if top is greater than or equal to n minus 1, size minus 1, we will say that stack is full. Else we will read the element which you want to push, and then top will be incremented, then stack of top is equal to x. So that is what the push operation is. Fine. So this is what about the push operation, how we are implementing that. Fine. Similarly, the pop operation, if you take it as, so if top is lesser than or equal to minus 1, then stack is underflowing, that is stack is empty. Else the popped element is nothing but stack of top, and after displaying this popped element, we are decrementing the top minus minus. Fine. So this is what the pop operation is. Then next display operation, which is used to display all the elements from the stack. So if top is greater than or equal to 0, print the stack, the elements in the stack, or for I equal to top, I greater than or equal to 0, I minus minus, printf percentage the stack of high value. So once you print that, if top is lesser than 0, then stack is empty, we will print that. Fine. So now the reflection part 1 here. So which of the following is true about stack data structure? Any students can answer this question. Fine. Stack is a linear data structure, right? This option A is also right. Stack follows last in first out. So it is also called as a LIFO data structure. Last inserted is the first to be removed. Then stack can be implemented using arrays as well as linked list. Yes, it is also right. And the applications of stack, if you see that stack is used in recursion also. This is one of the applications of the stack. We will see that. Fine. So if you are not able to answer these questions, please watch the video from the beginning. Fine. So the lecture outcomes are revisited here. After completion of the session, students will be able to implement all the stack operation using arrays. And summary of this today's session is that, so we have defined the stack. It is an ordered collection of homogeneous data elements, which are insertions and deletions can take place at one end only. And the important operations that we can define within a stack are insert, which we can call it as a push, and the delete operation, which we can call it as a pop. And these operations are done at one end only. That is what we are calling it as a top end of the stack. Fine. So this is a lecture level practice problem. Write a program to implement all the stack operation using arrays. And this is what the further reading corresponding to this particular stack topic. Okay. So thank you one and all.